On 7, what did you get for your measurement 0 to 30 degrees north latitude? 38. Everybody get something close to that? Okay. And then what about your measurement on 30 to 60? 28. Okay, everybody get something close to that? Okay. And then 60 to 90? 10. Okay, I had 11, so yeah, close to that. All right, what about your percentages then? So the first one, 0 to 30, what's your percent? 51, 50, something, somewhere close to half, right? Okay, and then on 30 to 60? 37. I got 36. Is that okay? And then 60 to 90? 13. Okay, I had 14, so something close to that. Okay, so what does that tell us? Well, that tells us how much of the incoming radiation is concentrated in those zones. So if you're in 0 to 30 degrees north latitude, you're getting half of all of the incoming radiation. If you're in 30 to 60, you're getting just a little more than a third. And then if you're 60 to 90, you're getting less than 15%. Okay, so that speaks to the intensity of the sunlight, right? Okay, what about number 8? We measured the angles, okay? Angle A, what is the measurement of angle A? 90 degrees, okay? Angle B, they told us, was 60. Angle C, 30. Angle D, 0. Okay, so again, that speaks to intensity because we know the higher the angle, the more intense sunlight. Now, if you look at this belt, or these different zones, I guess you could call them here, do you know where we are located? Do you know the latitude where DeQueen, Arkansas is located? Well, Google it. Look, use your phone right quick. Number 9. Describe the relationship between the sun angle and the amount of radiation received in each 30-degree segment. So the relationship between the sun angle, which we looked at in number 8, and the amount of radiation, which we calculated in number 7. So what is that relationship between angle and amount of radiation? What fact about Earth creates the unequal distribution of solar energy that you noted in question 9? Yeah, it's spherical, right? It's round. So, if it was a square, then every place on Earth would receive equal sunlight, right? So we'd all be the equator at that point, I guess. The variations in solar energy throughout the year. So we get seasons, right? As we look at the relationship between the Earth and the sun. So the amount of solar radiation that we get throughout the year depends on several things. Number 1 is that the Earth rotates on its axis once a day, giving us day and night. Okay, so one side is always facing the sun while the other side is facing away from the sun. Okay, so that's the first thing. Number 2, it revolves around the sun. Okay, so every year we make one revolution around the sun. Okay. Number 3 is that the Earth isn't straight up and down on its axis, right? It's tilted. So the Earth is tilted around, 23 degrees perpendicular. So it's not sitting straight up on its axis, okay? And then throughout the year, the axis of the Earth points to the same place in the sky, which causes the overhead vertical noon sun, to cross the equator twice, as it goes from what we call the Tropic of Cancer and the Tropic of Capricorn, which are at 23.5 degrees latitude. So the tilt is 23.5 degrees. So at 2 points during the year, that point matches up with the Tropic of Cancer and the Tropic of Capricorn. So what does that mean? Well, the intensity and duration vary as we go throughout the year. And that's why we have different amounts of daylight throughout the year. And it's why we have seasons. It's why we have different temperatures throughout the year, right? So let's look at the bottom of page 222. You've got this diagram here, okay, showing 4 different points in the year with the earth going around the sun. Okay, so let's fill in some of these blanks here. Okay, so, and I'm looking at where I'm getting this from is on number 2 on page 223. It says use figure 13.4, which shows the position of Earth on the traditional first days of summer, fall, winter, and spring to complete the following. The June dates are already provided. Okay, so write in the date represented by each of the other 3 positions. All right, so you've got the labels here. So if we start all the way on the left, they've put the date on there for us, June 21st or 22nd. That's considered the solstice. What solstice is that for us? Summer. Okay. So then directly across from that is another solstice. What solstice would that be? Winter. So what is the date of the winter solstice? December 21st. 22nd, 20th, somewhere around in there, right? We're coming up on it in about a month. We're coming up on the winter solstice, okay? So then opposite of those, we have the equinoxes, okay? What does the word equinox mean? Equal what? Equa means equal. You know what nox means or refers to? Night. So basically, equinox is when we have equal night. We have equal periods of light and dark. Okay? So the one at the top, is that going to be for the northern hemisphere, is that going to be the spring or fall? Spring, right? And what date is that? Yeah, somewhere around March 21st, 22nd, something like that. And the one at the very bottom, what's that one going to be? September 21st or 22nd, that's going to be our autumn or our fall equinox. And so the reason why they're called equinoxes is because we have 12 hours of sunlight and 12 hours of not sunlight. Okay. All right. Now, the other thing we're looking at on this is it says label the circle of illumination, which is the line separating the dark half from the lighted half of the earth on each globe. So you can just put the initial CI and just kind of, obviously we can't draw a 3-dimensional structure on a 2-dimensional piece of paper. So just label where the CI would be or is for the circle of illumination on each of those 4 pictures. Okay, and that's where the circle of illumination is the line that separates the light half from the dark half, and you could just put CI if you want to on each one of those.